Determine the surface area by rotating the region about the y-axis. And we're looking at this parametric curve. Let's quickly take a look at the graph and see what it looks like. So we have our x 3t minus t cubed and our y to be 3t squared. Let's go to the window and make sure t is between 0 and 1 as given. Also keep in mind when t is 0, I am at the ordered pair 0, 0. And when t is 1, I'm at the ordered pair 3 minus 1, 2, and 3. So I want to make sure I go at least to the y value of 3. Let's go to y max to be at least 3. And our x coordinate at least 3 is fine too. So let's just go take a look at the graph of that. So there's the region we're interested in, and we're going to rotate this about the y-axis. So flip this around and rotate it about the y-axis. It's going to look like a bowl. We're going to be interested in what the surface area of that bowl is. So our curve rotated about the y-axis this time. So we're interested in the surface area of this bowl-looking region. I'm doing a y-axis rotation, so 2 pi x ds is what I'm looking at. I'm going to go find my ds. We got our dx dt and our dy dt. Let's square both. In computing our ds, we square dx dt, dy dt, and do a little bit of algebra. Square this binomial. Don't forget you can't square them individually. You have to write 2 binomials and multiply it out. Square this guy, and it looks like we can combine some like terms. Once we combine like terms, it looks like they have a 9 that we can factor out. And once we do that, it looks like I have a nice binomial squared, because t squared plus 1 quantity squared will get me back to this trinomial. And that simplifies to 3. Just t squared plus 1. I have square root of 9 and square root of this guy, which happens to be a positive quantity. So we got our ds. Let's go put it back in. So there's our surface area as of now, but again, I got actually it was an x-axis or y-axis. It was a y-axis rotation, so it's really 2 pi x ds. So let's go replace the x with what it should be. X in this case was 3t minus t cubed. So we put in the 3t minus t cubed for this guy. And then we got some simplifying to do, it looks like. So I pulled out this 3 and this 2 pi, 6 pi, 0 to 1, and it looks like I got a couple of binomials to multiply out if I'm going to choose to do this by hand. I will probably also go look at the TI. So multiply that out, clean it up a little bit, and we get to here. Integrate the polynomial, and we're going to end up with 6 pi times this business is going to give me 11 over 6, and our final answer will be 11 pi for the surface area. Okay, let's say right here if I wanted to just use my calculator, I would go to math 9, of course, and then put in my function 3t. You'll see t's because I guess I'm still in parametric form, but I'll specify that I want it in terms of t, so I have t squared plus 1. So I put this times that, comma, my variable is t from 0 to 1, and hope that this can give me something that could be an exact answer. It should be, we know that it should be a rational answer without the 6 pi put in, equals. Okay, so that's what we get. At least it's a repeating decimal, that's good news. So I'm going to go to math 1, and I'm going to push enter. That's going to give me what it is as a fraction, which is what we got here. So then I just take my 6 pi and multiply it by 11 over 6 without having to go through this integration myself, because it's just a polynomial, of course, and we know at this point how to integrate that, so we'll end up with 11 pi. So once you get to a certain point, if your answer is not going to be irrational, you can try to use the calculator to punch out the value of the integral.